Hello everyone, so today I'm going to talk about the same topic, the flow measurement, the latest topic that we have studied. I'm going to start with um, the continuous problem from last video. So in this case, we're trying to find, for this problem, we're trying to find the alternate depth and like okay, so let's read the problem together. Like water flows at a depth of 10 centimeters with a velocity of 6 this one is meter per second, sorry. It's a typo. In a rectangular channel. So is the flow subcritical or supercritical? So as you guys see the word subcritical or supercritical, what do you think, like what is the thing that comes up to your mind? Of course, it's the fruit number, right? So it depends on if the fruit number is larger than 1 or less than 1. So now let's check the fruit number together. So now let's remember this. The depth is 10 centimeters and the velocity is 6 meter per second. So now let's check the fruit number together. So it's Fr equals to velocity over the square root of gy, which is gravity times with height. And from the above, it's 6 meter per second. The gravity is always, let's use 9.81 times with previous one is 10 centimeters, so it's 0.1 meter. So the answer will be the answer is 6.057. So you can see this is larger than 1. So if it's larger than 1, it means that the flow is supercritical. You actually don't have to write it this long, but in case you want your answer sheet to be super formal, I'm just kidding. So it depends on if you just like, you can also like, therefore, flow is super critical. It's up to you guys. There are many ways that you can, like make your answer sheet unique. So yeah, it depends on how you prefer to sum up your answer. So all we need to do next, they ask for the what is the alternate depth. So for the alternate depth, we're going to use the equation E. So find the alternate depth. E equals to y plus u squared over 2g. So we're going to substitute all the numbers. Y is 0.1 meter, which is 10 centimeter, so we convert it into meter. And u velocity is always is also the same. 2 times 9.81 meter per second. This is quite easy if you can remember the equation. So you can just substitute all the numbers in easily. And meter. Let me recheck my answer again. Okay, so now we have got the final answer, therefore alternate depth is sorry, I made a mistake here. It's 0.405. So I'll just go with 6. Okay, so now we're done for this question. Yeah, so we can move on to the next question together. So for this question is quite long, I guess. Long questions are normally hard, or it's like normally long questions are meant for shorter answers, but I think it doesn't confirm in this subject, right? So a 10 feet wide rectangular channel is rectangular channel. It must be something like this. Is very smooth except for a small ridge that is roughened with angle irons attached to the bottom of the channel. So water flows in the channel at the rate of 200 CFS cubic feet per second at a depth of 1. This is actually 1.0. I mean, a lot of typo, sorry. So assume the frictionless flow, except for over the roughened part. So where the total drag of all the roughness, so this all the roughness is it points to the angle irons, is assumed to be 2,000 pounds. So determine the depth of at the end of the roughness element for the assumed conditions. So we need to use the momentum equation in order to solve this. So there is like the downstream, right? So of course the water has an upstream and the downstream. So I'll use this paper to summarize it. To solve this question. So now let's use the momentum equation. So for this momentum equation, we are going to find it's the gamma y1 square over 2 minus gamma y2 square over 2 minus F, which is the force A, let's say it's point A, or the B, which is the width, equals to minus rho, which is the density, u1 square, y1 square, which is the velocity, u is the velocity. So I'm just like trying to remind what all these letters stands for, in case because I've been switching between all the symbols from what we have learned, so there might be some confusion if you have watched my video or skip the video and look at the the answer sheet straight away. So in case you look at the answer sheet, so you can just come back to look at the video and you will understand, or I mean not understand, you will get what kind of what kind of letters I'm trying to use for each terms. So in this case, we can also write this way: y1 square minus y2 square. So we're trying to get rid of the denominator. Oh, is it denominator or numerator? I'll find out about what is the numerator and denominator again. So B gamma equals to minus 2g gravity u1 square, which is the same, plus with 2g. So if the left side we're doing all those division and multiplication, of course the right side must be done the same because there's the equal sign. So equal signs mean whatever is done to the left side, it should be done to the right side as well. So this is 2 times with y2. This is also y2. So for the key was the flow rate. So FA is the force on the angle irons and B is the channel width. So we need to substitute all the numbers that we know. Okay, so what do we know about all of these? We know that the depth here we know the first step, and we also know the force, which is 2,000 pounds. So the first thing that we know is the depth, that is 1 feet, and the 2,000 pounds. Yes, and we also know the velocity, which is the flow rate, right? Yeah, the flow rate 2,200 cubic feet per second. Okay, so now let's substitute everything that we know. Let's put all the units that is given, so to avoid further confusion. We don't know y2, so let's just leave y2 here. We need to minus 2 times 2,000 pounds over 10 feet, which is the channel width, times with 62.4. So this is given as the gamma of the liquid, which is water, in the US unit, cubic feet. And then we have equal to minus 2 times with 20 feet per second square times with 1 feet. So as you know that the channel width is 10 feet, right? So then we can find the V by 200 divided by 10, which is 20. So now we can find the velocity. And after that we can write the G, which is the gravity, 32.2 feet per second square, plus with 2G, which is the 32.2, it stays the same, times with Q that we know earlier is 200 CFS over 30, it's already 32, right? B is 10 feet times with, okay, so y2 here we don't know, but this is supposed to be in square, right? Yes, everything here is supposed to be in square root, not square root, to the power square times with y2. So the thing here we don't know y2. So now let's compute all the possible numbers that we can compute, I guess. So we have the terms here that we can compute right away. 2 times 2,000 over 10 times 62.4 oh no more times 6.4102. So it's like 1 minus, right? So this is 2, okay. Equals to the right side here. So 1 minus answer here, it's minus 5.4110. Okay, so now we have the right side here. 2 times 20 times 1 over 32.2. So the answer is minus 1.24. It's 2, so I'll just leave it there. Then we actually know this part. This is actually you know, we cannot cancel this thing because it is square and it is only 1. So we cancel this one, it is like 1, so we need to put 1 arranged to the side. So now let's compute the coefficient that is in front. This first, 2 times 200 over 32.2 times 10. It's plus 1. Oh, wait. Why is it the same? Oh my god, it's the same, but it has something that is, so it's not gonna be 0 because it's having y2 down here. Right, so now we can, how do I do this? Okay. Okay, let's just write everything like this first. Over y squared, y2, and then for the parts that we can calculate, we will combine them together. Okay, let's do this. 5.4102 plus 1.242 equals to minus 4.1682. I will put it right here because this will be 4.1682. So I will put it here. The minus sign will be cancelled out. So it's 4.1682 plus 1.242 over y squared. Oh, y2. I keep saying y squared. Okay. My plan is to move this here, but we need to multiply by this, right, in order to cancel this one out. Oh, let's give it a try. 4 point, I think the solver can do this much, but I'm not really sure, so let's give it a try. Okay, yeah. Okay, so now we can move everything here. 1.242, it's minus, equals to 4.1682 y plus y2 squared. Okay, let's find y together. Minus 1.242 alpha equal to 4.1682 alpha x plus alpha x squared. So solve it. Let's wait for a while until it shows the answer. It's not showing the answer in solver. I'm going to try using the equation function. Wait a second. 4.1682 equals to minus 1.242. Okay, so the answer that I got is there are some numbers that we need to cancel out. So this is the answer that we have to, yeah, we got it for the answer. Okay, so now we have finished another problem. Okay, so it says determine the depth at the end of the roughness element. So now we have determined the depth already. Okay, the next question is it the same? Oh, it's not the same. So let's read the problem together. The water flows with a velocity of 2 meters per second and a depth of 3 meters. So in a rectangular channel, is the change in depth and in water surface elevation produced by a gradual upward change in the bottom elevation up step of 60 centimeters. So what would be the depth and the elevation changes if there were the gradual downstep of 15 centimeters? And what is the maximum size of upstep that could exist before the upstream depth change is the result? Yeah, the changes would result in. So we can neglect the head loss. Yeah, of course, in real life we cannot neglect all the head loss, but this is in the problem, so we're trying to do the ideal type. So now let's start the solution together. We're using this equation, y1 plus with u1 square over 2g. So the answer is 3 meter plus with 2 meters square meter per second times over 2 times 9.81 meter per square second. And the answer is 3.20 meter. Yes, not exactly. 3.101. Okay, so now we can find E2, which is equals to E1 minus delta head delta C. So it's 3.101 meter minus 0.6 meter. So the answer is 2.5019, so it's 02 meter. So on the other hand, E2 is also equals to Y2 plus with Q squared 2GY2 squared equals to, so in this case, we're trying to find Y2, right? So Y2 is still unknown. Q here, we know it, it's 6 meter cube per second over meter. So I would say it's meter square per second. It's like the flow rate, but it is calculated in the cross-sectional rate. Because normally if there's the flow rate, it's like the velocity times with the area, right? But this little q here is like the velocity times with the height. Or no, it's actually the q over height. So now we can find this one next. 2 times with 9.81 meter per second times with y2 square, which is we don't know yet. And then we can find this one. Oh, we don't have to find because it is already, we already found it there, 2.502 meters. So now we can use that to find in the solver. 2502 equal to alpha x plus 6 over 2.98 times alpha x squared. I'm afraid the solver is not doing its job because it's giving me in minus. So now let's go with the manual thing that we've always been doing. Y2 times 2 times 9.81 times y2 squared plus 6 2 times 9.81 times y squared. Okay, so 2y2, let's calculate this. 2 times 9.81, 19.62 y2 cube plus 6 equal to okay. Oh, nice. So now we have these three. 19.62 y23 minus 2.502. 502 is like the name of the glue, right? A very famous glue brand. 49.089 24. Do I need to put everything here? Okay, so now let's try again. 19.62 alpha cube minus 49.08924. The reason that I'm putting everything here because I'm afraid the answer will be something else. like we are missing some part is not accurate, so I'm doing all my best to put it right here. I'm going to use this equation right now. I cannot use this solver anymore. I also don't know the reason why as well, but yeah, it's not a quadratic equation, right? It's the normal equation is like the triple equation, so I guess we can use this one. 0, 8, 9, 2, 4. See, we don't have. Wait. Oh, I missed a D. 19.62 equals to, okay, this one is 49.08924 equal, and then D is minus 6. Please give me the answer to say 2.54, 0.36. Oh, and there you go, the other answer is in. Oh my god, why the answers are so strange? I'm going to use 2.54 here. So now we have 2 is equal to 2.549 meter. So now we can find delta y, which is y2 minus y1 equals to 2.549 minus, wait, what is the y1? 3, right? Okay, 3 minus 2.549, it's 0.451 meter. So in this case, 4.51 meter. Okay, so now we can find E2. Actually, for this E2, we're trying to find the downward step of 15 centimeters. So let's write like this: downward step of 15 centimeter. A2 equals to E1 minus delta Z. Delta Z is 0.6 equal to, okay, so for E1 that we have obtained earlier, it's 3.101 meter minus 0.6 meter. Yeah, it's actually exactly the same as the previous one. Oh, sorry. It's not 0.6, it's 0.15. It says, it changes the down step to 15 centimeters, so it's 0.15. The answer is 2.951 meter. So now we can see that, okay, so now let's substitute it like the one earlier, it's E2 equals to Y2 plus Q squared over 2GY2 squared. This will be the same because we're trying to find Y2 plus 6 meters squared per second. 2 times 9.821 times Y2 squared equals to 2.951 meter. Okay, so please give me some time to calculate this one. $19.62. For B is 2.951 times with 19.62. C is waken and B is -6 as normal. For this one it's minus 2. Okay. Don't forget the minus sign because we're trying to arrange it from the right side to the left side here, right? So this is minus and this is minus, but this stays the same because it stays at the right side. For this case, I got y equals to 2.985. So now let's do this. Delta y equals to y2 minus y1 equals to -3. The answer is a very nice number. -0.015 meter. Okay, so it seems like yeah, the number is a little bit strange, but okay. So now we still can see that the water it keeps dropping because yeah, it keeps dropping. Yeah, if there's a minus sign, oh, there should be a minus sign here, right? So if there's a minus sign, it means that the surface drops, it doesn't rise. So the maximum upstep possible before affecting the upstream's water surface level is for y2 equals to yc. So now let's write the yc equation together. Yc is equals to, I need a larger space, Q2 over G. Everything here is square roots of 3. It's the cube, and then we have 6 meters squared per second. Square over G is 9.821 square root of 3. Wait a second. Shift square root of 3, 6 squared over 9.81. Answer is 1.54 meter. So this is the answer for YC, which is you need this you need 1.554 in order to have the maximum upstep before affecting the upstream water level, because you need this YC equals to Y2, but all our Y2s are quite different from what we need. So yeah, that's it for the answer. I'll copy this to the page that contains the exercise, so I'm not wasting the space here. Okay, so then yes, we're doing so well. So we're moving on to the next exercise together. Okay, so now it says that the spillway shown has discharge 1.2 meet 1.2 cubic meter per second. Cubic meter per second per meter of width occurring over it. So what depth? Y2 actually is not y squared, okay, it's y2, the meaning 2 is lower here, will exist downstream of the hydraulic jump. Assume the negligible energy lost over the spillway. You know what the spillway is like, right? I'm not good at drawing. Yeah, you can search it in the Google. It says that the spillway will look like that. Okay. Yeah, I'm a bit tired today. You can tell from the sound, right? Okay, so this problem is quite easy as well. Do you want me to play some music? I can play some music while I'm recording the video like this, okay? Y0 equal to, not equal yet, plus with Q. I don't know what it's called, but I know that the formula is derived from Q, the larger Q, larger Q. What is this Q called? Yeah, capital Q. Capital Q equals, no, Q, the smaller Q equals capital Q over H. H is the height. Or, what do we call the other word for that one? I forgot it again. But I know the formula, I know where it's from, okay? I just don't know like what it's called or something, yeah. GY02 equals to Y1 plus with Q here, square over 2GY1 square. What do we have to do next? Oh, we have to substitute those numbers. Substitution. So then we can have 5 meter plus with 1.2 meter cube per second, and actually it's 2, right? Okay, and then we have 2 times, you know all the units for this one, right? I don't need to write the unit again. I don't have space to write the unit anyway. So in this case we're trying to find a y1, right? So let's leave y1 here. We have this one is 1.2 meter square per second, and then we have 2 times with 9.81 times y1 square. So now we know the left side. We know everything from the left side. We can compute this number together. 2 times 9.81 times with 5 square. The answer is 5. Oh wow, it's nice. 5.0024 4, I would say it. I'll just give it 2. I wonder if it's the unit is in M. Guess so. Okay, we have y1 here plus with, I used to like calculation a lot, but then I start to find it hard because I'm getting used to doing Excel. Not getting used, but I prefer calculating in Excel. It's a lot faster because all the formulas are already it's formulated for doing all the calculations, so why not use it in the exam room as well? And we may like bring our computer and do our Excel in the room, maybe in the future. Okay, so I see something is coming. This would be y1 cube plus with 0.0612 equals to 5.002 y1 square. Should I use this or use the other one? Okay, I'll just use this one. B is equal to minus 5.002 equals C has no value, and then it equals to minus 0.0612. Answer is 0.1110. Oh, it's 1111. We actually have like the conditions in selecting the depth, because we normally get 3, right? But we can see that if it's minus, it's impossible. So we need to look at like which one is the supercritical and which one is the subcritical. That's why in the previous exercise we were trying to find the where is it? We need to find like which one is the supercritical and which one is the subcritical one. It's gone. Is it here? Yeah, we need to know like which one is the supercritical, which one is subcritical. So if it's the supercritical, so when the number is like there are 3 cases, we can, there are 3 cases like this one, we can choose the right one together. So it's like, it's not larger than 1 or less than 1, it's larger than the existing one, like the existing depth. So that's why we need to check, because the value will be given in many possible answers. Okay, so now we get y1. So we can continue to find the fruit number equals to q here, or square root of, why is it doing like this? I don't like it. I'm not having OCD, okay. I just don't like things that are not completely good. I'm not a perfectionist, but I prefer things to be in the right way, because I also have like bad handwriting, so I'm not a perfectionist. But I want it to be like, not a flawless, but you got what I mean. I usually like spills out my mind during nighttime, so if you're watching the videos that I record at night, you will see many surprises. Okay, so now let's go back to what we're studying. 1.2 over square root of 9.81 times with 0.111 triple 1. The answer is 1. Oh, I forgot, this one is square. the answer is quite surprising to me. It's too much for me. I would say 12.43. It's larger than 1, of course. So then we can find dy1. I think you have seen this equation before in our class. Equals to y1 is like 1 over 2, right? Half of it. Square root of, or seen from my previous video, plus, I'm not sure if it's in class or in my video anymore. It's so confusing. Equals to 0.123 over 2 square root. Why did I get this number? It's 111. 1 plus 12.43. So we're not trying to find a fruit number to identify if it's a subcritical or the supercritical. We're only trying to find a fruit number in order to substitute in this point. Okay, so now let's work on the numbers together. 0.111 over 2. I'm trying to speak as slow as possible. I don't want to wake up my neighbors, but I can't help recording in the morning because the weather is too hot for me to turn off my fan. Because if I turn on my fan, it would be like the sound is disturbing, right? Like the one of the previous video. So it's 6, 3, 6, 5, 7, 8. So this is the answer. Are the letters too small? But you can always like zoom in and zoom out, right? Okay, so now we have finished this one as well. Oh, let me see how many else do we have? I think this one is already done. Yep, we have done this one already. So we can move on to the next. We can skip 19 and then go to 20. Wait. Yeah, we already did this one. Why is everything duplicating? So we have 21, 22, 23, 24, 25, and 26. Okay. Let's finish 21 by today. So I think we can finish 22 by today. What is the head on a rectangular weir is 60 centimeter high. In a rectangular channel, measure the channel to be 21 centimeters. So what is the discharge water over the weir? Oh, this is so easy. Do we need to add a square paper because it's quite easy, of course. So that's 2130 and 1.3 meter. Okay, so now first of all, let's find the flow coefficient together. Flow coefficient. K equals to 0.4 plus 0.5 H over P. It says the rectangular weir, right? So this is the formula, and we have, okay, I'll just write this rectangular weir. So this would be 0.4 plus 0.5. H is 21 centimeter and lower part here is 60. I keep saying the lower part and the upper part. Actually, the one of them is the denominator and the numerator. But I keep messing them up, so I'm afraid that I cannot use the number. I mean, use the term right. 0.4 plus 0.5 times with 21 over 60. The answer is 0.575. Okay, so the flow coefficient doesn't have any meter doesn't have any units. So then we can find the discharge. For the discharge, Q equals to K, which is the coefficient that we have found earlier, square root of 2, actually it's not that big, it's only 2G, times with L, length and the height, 3 over 2. Wait, this is the what? The width? I mean, L is the width. Yeah. I mean, actually, it's quite confusing because all the things are quite like, the lap what does it call in English? I'm losing my English. It's swapping. Yeah, swapping. So that's why you need to be careful when substituting, because sometimes you think that substituting are easy, right? But you need to look carefully which one is which one, because in this part all the things are not when we learn in the kindergarten, our teacher always say that the numbers are multiplication can always swap together, like back and forth. But now we're studying in the university. Since high school, we cannot swap it because the power is not the same. So that's the reason that I'm warning you guys to look carefully which one is the width, which one is the height, because in some exercise they're swapping a lot. Or you can just remember that the length is always larger, bigger than the height. I'm not sure if it's always, but from what I've been doing, from all the exercises that I've been solving, I think most of them are that way. Times square root of 2 times 9.81, and then times with 1.3 times with 0.21 to the power of 3 over 2. The answer is 0.231 cubic meter per second. Okay, see all the exercise. I'm not trying to find the exercise that are too hard for our level, because the teacher will have some mercy on us. I hope so. Okay, so we found the answer. I think the time is not sufficient enough for us to continue to the next exercise. We only have 6 minutes left, so let's read the exercise together, and we can finish it in the next video. Oh, did I delete everything? Okay, it's here. I just did another typo. It's proposed. It's proposed. It is proposed to use a. Sorry, I haven't checked the pronunciation for this word. Knock. For measuring the water flow from a reservoir. It is estimated that the error in measuring the head above the bottom of the knock could be 1.5 millimeters for a discharge of 0.3 cubic meter per second. So determine the percentage error which may occur using a right angle triangular knock with the coefficient discharge of 0.6. So I think the time is still good for us to draw. Um, this is what the knock would look like. I'm trying to show that this is 90 degrees. Yeah, this is right angle knock. Knock. No, this is not what it looks like. Oh, it is. It is what it looks like. And then this one would look like this. Okay. Copy. Paste. Oh, no, wait. I need to copy this one, right? I'm not sure if the picture is right, okay? Because this is not from the original picture. It is like what I imagine it to be. So it might be a wrong picture, who knows? And I won't betray you guys, so don't worry. It's the right picture. I mean, it must mean this way, right? Okay, so here is the it's water, right? So water should be in this color. So the water is flowing like this. Here is the water. Okay. Okay. So the water is flowing like this. And the error measuring the bottom of the knock would be 1.5 for a discharge of, okay, so the water is flowing at 0.3 cubic meter per second. And they're asking the percentage error which may occur using a right angle triangular neck here. So why did they tell us to it is a right angle? Because we need to use it, right? So the alpha is equal to 90 degrees. In this case, we're going to use this formula. Here I'm not writing in pen because I know that I will be continuing the next video, so yeah, stay tuned. So Q equals to 8 over 15 CD H 5 over 2 square root, I forgot 2G tangent of alpha over 2. So yeah, you can try it at home. This is the homework that I'm going to give you guys until I post the next video. Okay. Yep. Yeah, I'm trying to point my laser still so that you can take a screenshot or something, because this is the formula for the triangular knock only. Don't try to use it for other, because each shape has their own formula for the rear stuff thingy. Yeah, it's gone. Okay, so now I will come back with the next video and show you what to do next. For this one is also the same. I think it's very similar. Okay, so the two of this and this is not included. We have done 2, 3, 4, 5 today. All done in 1 hour. I'm so proud of you guys. Yeah, so now we have 1, 2, 3, 4, 5 more. So it will probably take around 1 hour to 2 hours to finish the remaining, because the remaining is quite easy as well. Maybe 1 hour to 1 hour and a half. Okay, so thank you so much. Bye bye. Don't forget to do the homework that I gave you. Okay, see you next video.